So I got a Karcher K4 Compact pressure washer here. This is the second one I've had, and it's completely dead. Connect it up, switch on, and there's absolutely nothing. So we're going to take this apart, see what the matter is. Hopefully some of you guys can fix your own, because I believe these are unreliable. First thing to check, of course, is the fuse, which is fine, 0.2 ohms, as you can see there. So put the thing face down on a cloth so you don't scratch it, and the access screws are in the back down these deep dark holes. These are Torx, standard Torx T15s, and you need something with a longish reach to get into them. So there should be about 6. Once you've undone those, you can just lift the back away like so to expose the pump, which is cooled by its own pumping water. Make a note of where the cable goes in and the routing of the cable beforehand, so you know how things go when you come to put it back together. The pump simply lifts out of the case. We'll leave the case looking like that, and you just need to leave that be. Incidentally, this is the tool I use to open the thing, which is great. You can put any size bit in the end, and it's on a ball bearing. Very handy. So the next job is to get into the electrical bit here. Now to do this, you need to take the top off of this. So unscrew the clip on, and then you'll need to undo these 6mm hex bolts, of which there are 4. So once you've wiggled this free, this is what you're left with. So bear in mind these are prone to fall off, so be a little bit careful. But you can now access the electrical components here, and these electrical bits will come away here. Now down here are where the cables go into the motor, so don't pull on this. You'll need to disconnect the earth lead, and then we can get to doing some testing. So just go around it slowly with a flat bladed screwdriver until the top comes loose, and then you can gain access to the cables. So we can test continuity between the plug here and the mains plug, and see if this is a problem with the motor, the big capacitor on the back there, or whether it's the cable itself. General rule while looking at capacitors, short them out before you start fiddling, just in case. I don't think this one's charged, but you never know. So here, just doing a little continuity checking between the live pin, and you can see behind the switch there's the blue for neutral, and on the other side the brown for live, right in there. Just check those. In this case, both of those are fine, so we'll check the output of the switch, and providing that's alright, we haven't got a switch, a plug, or a cable fault. So by looking closely in here, we can work out that the outputs from this, and as you can see, I've simply separated the multi-plug there from the bottom of here. You can deduce that the center pin is live, the right hand pin is neutral, and there's the capacitor across the outside 2 pins. So having verified these contacts here, we'll check these on the motor. So this is the motor component with the pump mechanism removed. Bear in mind, it looks like there's a bit of an emulsion going on in there. I think water's got in, so it's worth wiping that out with a paper towel and putting some new high temperature grease in, just to make sure it keeps running well. So to get the motor out, we've got to undo these star bolts. Probably get a T20 actually in there for a better drive. Okay, so that's the bolts removed. Now bear in mind this is a tight fit. There are some O-rings you've got to take care of. There are two small ones here. There's a big one just under there. And if you flip this upside down, there's an O-ring between the metal motor housing and the plastic shroud. Now bear in mind, this motor is cooled by the water that it pumps, so the water goes in, circulates around the motor in this plastic jacket, and then comes back out here to be pumped, which is a nice enough design until your O-rings start to leak. Incidentally, that's a common cause for these Karcher K4s to leak, usually from the bottom O-ring, and you can get an O-ring set for these. Just need a bit of silicone grease to make them absolutely good. So I'm going to separate this. It needs a bit of jiggle joggling, and that will push through, and we'll be able to get at the motor itself. So we got it on the bench here. It's a bit less windy. Easiest way to get this off is to push down on put it on a flat surface and push down on the black plastic bucket downwards fairly evenly, and it should just sort of pop off the O-rings. Bear in mind, when you put it back together, don't get those O-rings trapped, otherwise it'll leak like billy-o. So that's the outer jacket. Bear in mind there might be a bit of water trapped in there, so have a bucket handy and not one of those underneath. Pop that aside, and then you see the motor here. Pop this in, and you should find the top will come off. There we go. So there it is. There's a little delicate gasket, you'll need that, so look out for that. We'll set that aside. Incidentally, underneath here, if you're cleaning it out, there's some ball bearings. Again, as I said before, just worth re-greasing that. So pop that aside and get back to our motor. Now then, this is what we're going to test electrically, and as I've found before, in here there's usually a bulky bit. It's about here. There's generally a solder joint which, as the windings get warm, it tends to desolder it, so maybe with a vibration as well, it tends to desolder itself. So we'll check the continuity on these pins, and then if necessary unwrap some of this on the top. Bear in mind you might need to have some capped on tape and some small cable ties available to put it back together afterwards, but I'll show you that as we get to it. Okay, so if we remember our markings from before, this is live, this is neutral, and this is the capacitor. This connector is keyed, incidentally, so you can't put it in the wrong way up. So this is a nice gadget, capacitance checker, 29 microfarads, a reasonable series resistance of 0.1 ohms. So I think that capacitor is probably good, but let me just check the specs on it to make sure that that's an appropriate figure. You may not have one of these, but on the multimeter very often there's a capacitance checker. And here we can see the specifications: 30 microfarads plus or minus 5%, so it appears to be within specs. So all seems to check out well. So the motor windings all seem to check out okay. About 7 ohms between capacitor and live, about 5 ohms between live and neutral, and about 12 ohms between capacitor and neutral. So maybe just been a bad contact. What I'm going to do is put all this back together again and see if we can get some action. So this is the motor back together. When you're tightening this row of bolts and also these, if you do them on diagonals as if you were doing wheel nuts, it'll probably come together better. As I said before, just make sure you've not trapped the gasket underneath there, and that all of these pipes are fitting in their right holes. So if we check the continuity across live and neutral pins with it in the switched on position. So there we go, we've got continuity, about 5 ohms, so whatever else is going to happen, it's not going to be dead. So we'll put it back in its case and try it out. So this is it back together again. Working normally. Job done.